An output device takes binary data from the computer and turns it into something a person can perceive. An image, a sound, a printed page, or into a physical action. And the exam pattern is identical to the last lesson. Questions ask how the device works, and they are marked on the sequence of steps in order. So again, what you are learning for each device is a short process, not a description. Let us start with the screen you are almost certainly watching this on. An LCD screen, liquid crystal display, is made of a grid of liquid crystal cells. Applying a voltage twists the crystals so that they either block light or let it through, and that is how each pixel is made dark or bright. Now here is the crucial property, and it is the one every question in this area turns on. Liquid crystals do not produce any light of their own, none. All they can do is block light or pass it, which means an LCD screen is useless on its own. It must have a backlight behind it shining forward through the crystal layer. If you understand that one fact, everything else about screens follows from it, including a piece of marketing that confuses a lot of students. That backlight is the thing that has actually changed over the years. Older LCD screens used CCFL backlights, cold cathode fluorescent lamps. Modern ones use LEDs instead, and that is the whole story behind the label. A television sold as an LED screen is an LCD screen with an LED backlight. The picture is still being made by liquid crystals. The LEDs are only the lamp behind them. So if a question asks why LED backlights replaced CCFL, there are 6 answers, and they are all worth knowing. They use less power, which matters enormously on anything running from a battery. They are brighter, with better contrast and color. They light instantly, with no warm-up time. They are far thinner and lighter, which is why screens got flat. They last longer, and they contain no mercury, unlike CCFL, so they are less harmful to dispose of. Light projectors. Both types throw an image onto a screen, but they form that image in completely different ways, and the difference is worth understanding rather than memorizing. An LCD projector shines a bright light through a prism or set of mirrors, which splits it into red, green, and blue. Each color then passes through its own small LCD panel, which forms that color's share of the picture, and the 3 colored images are recombined and sent out through the lens. So an LCD projector transmits light through panels. A DLP projector, that is digital light processing, works by reflection instead. At its heart is a DMD chip, a digital micro mirror device carrying millions of microscopic mirrors, one for every pixel. Each mirror tilts either towards the light source or away from it, thousands of times every second, and the proportion of time it spends tilted towards the light sets how bright that pixel appears. Color is added by a spinning color wheel between the lamp and the chip. So, LCD passes light through, DLP bounces it off tiny mirrors. Their strengths follow from those 2 mechanisms. The LCD projector gives a sharper image with richer color saturation, but because you are looking at light coming through a panel of pixels, the gaps between pixels can show as a faint grid, the screen door effect, and its contrast is lower, so blacks look grayer. Its filters need cleaning. The DLP has a higher contrast ratio and genuinely deeper blacks, a smoother image with no visible pixel grid, and it is more reliable with longer lamp life. Its one quirk is the color wheel. Because colors are shown in rapid succession rather than simultaneously, some viewers briefly see a rainbow effect when their eyes move across the image. Now the printers, and there are 3 of them on the syllabus doing 3 quite different jobs. An inkjet printer works like this. A sheet is fed in and held by rollers. The print head moves across the paper, spraying extremely small droplets of ink onto it. Those droplets are produced by one of 2 mechanisms, and the syllabus names both. Thermal bubble. The ink is heated so that a bubble forms, and the expanding bubble forces a droplet out of the nozzle. Or piezoelectric. A crystal changes shape when a charge is applied to it, and that movement pushes the ink out. Then the rollers advance the paper slightly, and the head makes its next pass until the page is finished. Inkjets give excellent quality on photographs and color images. They are cheap to buy, and they are small and quiet, which is why they are the standard home printer. Against that, They are slow, the cartridges hold very little ink and are expensive to replace. Wet ink can smudge and the nozzles clog if the printer sits unused. A laser printer works on a completely different principle, and this is the one candidates most often get wrong, because the thing you notice about a laser printer is that it is hot, so people reach for heat as the explanation. Heat is the last step. Static electricity does all the real work. Here is the sequence. First, a rotating drum is given a positive electrical charge across its whole surface. Second, a laser beam scans that drum and reverses the charge at every point where the image is to appear, so you now have an invisible electrostatic picture drawn in charge on the drum. Third, negatively charged toner, which is a dry powder, is attracted to the reversed charge areas, so it sticks to the drum only where the image is. Fourth, the paper is given a charge and passes the drum, pulling the toner off it and onto the page. Fifth, and only now does heat appear, a fuser applies heat and pressure, melting the toner so that it bonds permanently to the paper. And sixth, the drum's charge is removed, ready for the next page. Notice that the whole page is produced at once, rather than swept across line by line, which is exactly why laser printers are fast. So the comparison writes itself. Laser printers are very fast, and faster still the longer the print run. Their cost per page is low because toner lasts far longer than ink, and the output is dry the moment it leaves, so it cannot smudge, but they are expensive to buy, particularly in color. The toner cartridges are costly, and they produce heat and ozone and take up more room, which means the choice in a scenario question is usually straightforward. High-quality photographs or occasional use at home, Inkjet. High volume, speed, low cost per page, and office, laser. Justify it with the named property, not by saying one is better. The third printer makes objects rather than pages. A 3D printer performs additive manufacturing. It builds a solid object up in very thin layers instead of cutting material away from a block. The design comes from CAD software or from a 3D scanner of the kind we met in the last lesson, and software slices that model into hundreds or thousands of horizontal layers. There are two methods to know. In direct 3D printing, a print head moves left-right, front-back, and up-down, depositing material, often molten plastic, one layer at a time. Each layer setting before the next goes on. In binder 3D printing, the printer makes two passes for every layer. It lays down a layer of fine powder, then sprays a binding glue onto just the parts that are meant to become solid. Materials include plastics, resin, powdered metal, and ceramic. The advantages are genuinely interesting rather than just listable. It can produce shapes that cannot be cut or molded in a single piece, because it builds them from nothing rather than removing material. One-off custom items become affordable. A prosthetic limb fitted to one particular patient costs about the same to print as any other. There is less waste than machining material away, and parts can be made on site instead of shipped, which matters for replacing components in old machinery no one manufactures anymore. The disadvantages: it is slow, often many hours for a single object. The equipment and materials are expensive, the range of materials is limited, and printed parts can be weaker than machined ones. And there is a genuine ethical concern which examiners do ask about. The technology makes it possible to manufacture dangerous or counterfeit items outside any regulated supply chain. Two more, quickly. A speaker. A digital to analog converter turns the stored binary sound data into a varying electric current. That signal is amplified, and it passes through a coil of wire attached to a cone sitting inside a magnetic field. The varying current makes the coil, and so the cone, move back and forth, and the moving cone vibrates the surrounding air, producing sound waves. Notice that a speaker is the exact mirror image of the microphone from the last lesson. There, a diaphragm vibrated and produced a current. Here, a current makes a cone vibrate, and an actuator is an output device that produces a physical action rather than an image or a sound. A motor, a valve, a heater, a buzzer. Actuators are how a computer changes something in the physical world, and they are the subject of the next lesson. 3 things to take away. An LED screen is an LCD screen. The LEDs are only the backlight. A laser printer works by charge, and heat appears only at the fusor, at the very end, and match the printer to the scenario using its named property. Photos means inkjet, volume, and speed means laser. An object from a design means 3D.